Here's some somewhat tricky problems that are given to you in your textbook on page 89. They give you 2 points and they want you to write the equation of the line in standard form. Well, the first thing I want to think of is what's the equation of a line in standard form? That's going to look like ax plus by equals c. So remember, this is kind of a useless form. I can't plug anything into that, so I have to do some math. So the first thing I know is a line always has a slope. So I want to figure out what the slope is. And I need to remember that the equation for slope, I'm going to write this right here, is the change in y divided by my change in x. So I'm going to label these. This is going to be x1, y1, x2, y2. So I'm first going to find the slope. So my slope is going to be 5 minus 3 divided by 4 minus 2. The order is very important. So 5 minus 3 is 2. 4 minus 2 is 2. So this simplifies to 1. So I know then that my slope is equal to 1. So let me think, what do I have? I'm given a slope, or I figured out the slope, and I also have points. Oh, well, maybe I should use point slope form. So that's not the form I want. It's an intermediary form, something in the middle. So let's remember, what does point slope form look like? That's going to be y minus y1 is equal to m times x minus x1. So I'm going to use that form. So let's pick a point. Let's use the point 2, 3, just because those numbers are smaller. So I'm going to have y minus y1, which is 3, is equal to my slope, which is 1, times x minus x1, which is 2. If I distribute the 1 in, that just gives me x minus 2. So this is going to be y minus 3 is equal to x minus 2. I don't need the parentheses anymore. Add 3 to both sides. So now I have y is equal to x plus 1. Well, I just put this in slope intercept form, but that's not what I want. So notice in standard form my x and my y terms are on the same side as my equals. X comes before y, and my constant is all by itself on the right side of the equal sign, which means I want my x to join my y. So I just need to move it out of there. So I end up with negative x plus y equals 1. So notice this is in standard form. This looks just like ax plus by equals c. So I'm done with that. Okay, moving on. Let's look at another example. This is slightly different. Here I'm given a point and I'm given a slope. I don't have to figure that out anymore, right? They're still asking for standard form. Let me write down what I have. I have a point and I have a slope. And standard form is ax plus by equals c. Oh, so if I have a point and a slope, I must need to put that in point slope form again. So that would be y minus y1 is equal to my slope times x minus x1. This is less work than the problem we just did before, but there's a little tricky thing going on here that I need to show you. So let's just substitute in what we have here. So this is going to be y minus y1, which is the value of 2, is equal to my slope, which is 4/5, times x minus x1, which has a value of 1. Let's go ahead and distribute. So this is going to be y minus 2 is equal to 4/5 x minus 4/5. Then I need to, well, let's put this over here. So let's go ahead and let's do plus 2, plus 2. And so then that's going to give me y equals 4/5 x. Well, let's see here. We've got this fraction thing going on. So let's look at the math I'm trying to do right here. Let me highlight this for you so that you can see it a little bit better. This right here is the math I'm going to do over here. So if I have negative 4/5 plus 2, this 2 needs to have the same denominator. Right now it has a denominator of 1. But that's not going to help me. I have to multiply this by a magic number 1. And that magic number 1 is going to take the form of a fraction. If this denominator needs to be the same, 1 times 5 gives me 5. What I put on the bottom, I put on the top. Because 5 divided by 5 is 1. It does not change the value of the 2. So now I have negative 4/5 plus 10/5. Now I can add that. And what do I get? So I end up getting 6/5, if I did that correctly. 10 minus 4 is 6. Yes. Okay, so then that means that this value right here is going to be a positive 6/5. Okay, so we can get the y, the x over with the y. So let's go ahead and do that. There's another way we could do this, but I'm just going to be consistent with how I did it in the previous example. So that leaves us with negative 4/5 x plus y is equal to 6/5. Now, if I want what's called integer values for coefficients, which is typically what we do, I can't have any fractions there in my, either for my a or my b. I have a 5 in the denominator. I want to get that out of there. So I'm going to multiply this whole thing by 5 in the numerator. So if I do 5 times negative 4/5 x, that gives me negative 4x. 5 times y gives me 5y. 5 times 6/5 gives me 6. So now I have a very nice answer in standard form. So you can see how we have to know all 3 forms of a line in order to manipulate from one thing to the next. The last example I'm going to give you is example 18. This is asking to write the equation of a line in standard form. So remember, standard form is ax plus by equals c. So I want my y with my x on the left, and I want my constant by itself. So let's move this constant over to this side. So that's easy. Let's subtract 3 from both sides. So now I get 2/3 x is equal to 6y minus 18. Let's get the 6y over there with my x term. So we're going to subtract 6y from both sides of the equal sign. So that gives me 2/3 x minus 6y is equal to negative 18. Okay, so let's look at this. Just as we did before, I don't want that in the denominator. So I need to multiply by 3. Because if 3 is in the denominator, I want to get rid of it. So I'll multiply 3 in the numerator. Notice how this is up above. That's important. So 3 times 2/3 gives me 2. So that would be 2x. 3 times negative 6 gives me negative 18y. And 3 times negative 18 gives me negative 54. So that is my answer in standard form.